rest, motion, and frame of reference. Objective: to understand the concepts of rest, motion, and frame of reference. When do we say a body is at rest, and when do we say it is in motion? When the position of a body does not change with the passage of time, it is said to be at rest. When a body changes its position with the passage of time, it is said to be in a state of motion. A car parked in front of a building appears to be at rest to an observer in the building. If the same car is observed from space, it appears to be in motion. Thus, rest and motion are not absolute. It depends upon the observer and reference frame from which the object is observed. If position of the object is not changing, it is said to be at rest. To study the motion of the object in the reference frame, we need to have a method to indicate the position of the object at any given time. If position of the object is changing in a reference frame, it is said to be in motion. We live in a three-dimensional space, so we need three variables to identify the position of any object. A convenient way to identify the position is to attach three mutually perpendicular axes x, y, and z to the reference point and to measure the distance of the object along these three axes. For example, an object's position is given as 10, -6, and 4. It tells us that object can be located by moving 10 units along the positive x-axis, then 6 units along negative y-axis direction and 4 units along positive z-axis direction. Let the object move from point A to point B along a path as shown. The total length of the path covered by the object from point A to point B is called the distance traveled by the object. Join point A to point B with a straight arrow. This arrow is called displacement vector. Even if the object takes different path between initial and final positions, the displacement remains same. Displacement is the vector joining initial point to the end point. Suppose an object moves from point A to point B along a path whose length is d, then the object returns to A along the same path. What is the distance traversed by the object and what is its displacement? Since distance is the total path length traversed by the chopper, it will be d plus d, which is 2d. As both the initial and the final positions of the chopper is A, its displacement is A bar, which is a zero vector. If the object moves further to point C, the total distance traversed by it is AB plus BA plus AC, whereas its displacement is AC bar. Summary. When the position of a body doesn't change with the passage of time with respect to a point of reference, it is said to be at rest. When the position of a body changes with the passage of time with respect to a point of reference, it is said to be in a state of motion. Displacement of an object is the vector joining initial position to the final position. Distance of the object traveled is the length of the path taken by the object.